Hello, good afternoon. Am audible? Am I audible?
Yes, sir. Audible.
So we'll start today's class. Shall we start today's class? Or shall we wait? Are you ready? Okay. We start the today's class. Now, before going to start today's class, first let us discuss about what we have done in the last class, that is yesterday's class. Yesterday, we have started the second part of the differential equation. The second part of the differential equation is ordinary differential equations. In the ordinary differential equation, there are four subtopics. There are four subtopics. Out of four subtopics, first one is solution of a differential equation. Second one is types of solutions of a differential equation. Third one is first order and first degree differential equation. And the last one is second and higher order linear differential equation. These are the four subtopics of the second part, or ordinary differential equations. So yesterday we have completed the solution, types of solutions, and then we have started the first order and first degree differential equations. Just let us recall what we have done in the last class. So yesterday we have started the OD, that it is the second part of the differential equation. In this, the first subtopic is solution. Solution means it is a relation between the variables. Because of ordinary differential equation, it will contain only two variables. One of the variable is independent, other variable is dependent variable. The relation between independent and dependent variables satisfying the differential equation is called solution of a differential equation. And there are two types of solutions. There are two types of solutions. One is general solution, other one is particular solution. Every solution may not be a general solution. In a solution, the number of arbitrary constants is equal to order of the differential equation, then such a solution is called general solution. What is the condition for general solution? In any solution, number of arbitrary constants or number of parameters is equal to order of the differential equation, then only such a solution is general solution. Otherwise, that solution is not a general solution. Next, other type is particular solution. From the general solution, we can add the infinitely many solutions for particular values of arbitrary constants or parameters. So if you write any solution from general solution for particular values, such a solution is called particular solution. After this, we have started the first order and first degree differential equation. In this, we have written the general form of the first order first degree. The general form of the first order first degree is dy by dx equal to f of x comma y. Not only this, we have other form also. Other form is m of x comma y dx plus n of x comma y dy equal to 0. So there are two general forms of the first order and first degree differential equation. This form is the derivative form or differential coefficient form. Other form is the differential form. One is the differential form, one is derivative form. We can add the first one in the form of second one, and we can add the second one in the form of first one. So both are same only. Here f of x comma y, m of x comma y, and n of x comma y. These functions should be continuous. These three should be continuous. Suppose some condition is given Then the condition along with the differential equation is called initial value problem. Next one is initial value problem. The general form of the initial value problem for first order first degree is dy by dx equal to f of x comma y with the condition y of x naught equal to y naught. Because of the first order first degree differential equation, its general solution contains only one arbitrary constant or one parameter. So to write the one parameter value or arbitrary constant value, we require only one equation. That is, we require only one condition. So every first order first degree with the condition is always initial value problem. From second order differential equation onwards, the differential equation may be either initial value problem or a boundary value problem, depending on the conditions. But every first order with the condition is always initial value problem. And here, y of x naught equal to y naught means y naught is the value of y at a value of x equal to x naught. After this, we have written the methods. Methods of finding the general solution of first order first degree differential equation. In the differential equation topic, whatever we discuss the methods, all the methods are called analytical methods, actual methods. Already I told you what is the analytical method only. Analytical method means if any method gives actual solution of a problem, that problem may be any mathematical problem. If any method gives actual solution of a problem or complete solution of problem, such a method is called analytic method. So in the differential equation, we'll discuss about all the analytical methods only. And we are going to discuss about 6 methods. Actually, there are 7 methods. Out of 7 methods, we discuss here only 6 methods. The other 7th method, non-homogeneous method, is descriptive method. We are not going to discuss that one. Very first method is variable separable method. Second one is homogeneous method. Third one is exact method. Next, fourth one is non-exact method. Next, linear method and non-linear method. These are the methods. Yesterday, already we have started the variable separable method only. In the examination, if a question is given from the differential equation, then they won't mention the name of the method in the question. In the examination, if a question is given from the differential equation topic, in that question, you will not find the name of the method only. Simply the question will be like this, the solution of the differential equation only. But we can identify the method by looking the problem. Because for every method, there is some condition. The condition satisfies, the condition of the method satisfies for the differential equation, we apply particular method only. So don't worry about all the 6 methods. At the end of these methods, you will be able to identify the method depending on the problem. So I will give that guarantee on it. I'll make you like that on, because for every equation, we verify the conditions and then we apply the particular method on. So don't worry about all the 6 methods only. For every method, there is some condition. We have started the first method yesterday, variable separable method, and also we have written the condition of the method. After that, the solution procedure, and then we have written one note point. After that, we have done 2 problems up to here, the last class. Now we continue the yesterday's class. Already we have done 2 problems on variable separable method, and today we do 2 more problems. After that, we go to the next method on. Actually, dy by dx equal to f of x comma y, or m dx plus n dy equal to 0. These 2 are the general forms of the first order first degree differential equation. In the function, in this differential equation, f of x comma y equal to h of x into g of y. Then we can set variables are separable. H of x means it is a function of x alone. G of y means it is a function of y alone. If you are able to separate variables, then we can solve the problem by variable separable method. But always the differential equation may not be given in the form of, always the differential equation may not be given in the form of dy by dx equal to f of x comma y. That equation may be given in the form of other form like this, mdx plus ndy equal to 0. In this equation also, m, n are in the form of like this. That is m equal to h of x into g of y. Again, n equal to h of x into g of y form. Then we can solve the problem by variable separable method. So if it is written as h of x into g of y, we can set variables as separable. But always this function may not be written in the form of like this. In some cases, the function may be given like this also. F of x equal to function of ax plus by plus c also. This function is in the form of function of linear expression. In this case also, we can separate the variables indirectly by replacing this expression with some other variable z. Two problems on these two. Let us continue the problems, yesterday's class problems only. Now I am writing the third problem. Problem number 3. Which of the following options contains two solutions of the differential equation dy by dx equal to y minus 1 into x? Question mark. Option A, ln after ln modulus of y minus 1 y minus 1 equal to 0.5 x square plus c and y equal to minus 1. Option B, ln means logarithm, that is natural logarithm, y minus 1 equal to 2x square plus c. Option B, log of y minus 1 equal to 0.5 x square plus c and y equal to 1. Option D, ln modulus of y minus 1 equal to 2x square plus c and y equal to minus 1. In option B, other solution is y equal to 1. Now it is a recent question for EC branch 2 marks problem, 2020 EC gate question, 2 marks problem. In every option, 2 solutions were given for the given differential equation. If you observe every option, one of the solutions with the arbitrary constant is C, other solution is without arbitrary constant. So from options, we can say that out of 2 solutions, one of the solution is given as general solution, other solution is given as particular solution, one of the particular solution out of many solutions. Now I am writing the given differential equation in the solution. Given dy by dx equal to y minus 1 into x, series 1. It is a given equation. It is one of the general form of the first order first degree. That is a derivative form. Dy by dx equal to f of x comma y. Since dy by dx equal to f of x comma y. If this f of x comma y is written as function of x into function of y, then we can separate the variables and we can solve this by variable separable method. Are you able to separate variables here? Check it on. In place of f of x, can you write the function of x into function y or not? Okay, yes, we are saying, most of them are saying yes, right? Because it is a function of y only, it is a function of x only. So variables are separable, we can solve it by variable separable method only. First, we rearrange the terms. Rearrangement means we write all y's at one place, all x at one place only, or one side. Y minus 1 dy equal to x dx, and then take the integration plus c. What is the integral of x? X squared by 2. What is the integral of 1 by x? Log x. Like that, integral of 1 by y minus 1. So its solution is log of modulus of y minus 1 equal to x plus this is x squared by 2 plus c. It is a general solution. Now, can you choose answer directly? Can you choose answer only with this general solution? Can you select the correct option by looking this answer or general solution? No, right. Just by looking this general solution, we cannot choose a correct option, because in the options, one more solution was given. Whatever we have done, this is only general solution. Now, to choose the other particular solution, we go for verification method only. If you want to say that y equal to minus 1 is a solution of this equation, the differential equation should satisfy with this y equal to minus 1 only. Let us consider the LHS part. LHS part of the differential equation is dy by dx only. RHS part of the differential equation is y minus 1 into x. We are checking this for only option A. Now in the option A, other solution is y equal to minus 1 only. Derivative of minus 1 is 0. When you substitute y equal to minus 1 here, minus 1 minus 2x. LHS is not equal to RHS. Therefore, option A is wrong. Next, option B. So y equal to minus 1 is wrong means option A is wrong, and option D is also wrong. Either B or C. One of these two should be correct. So let us verify the other one. But already we know the general solution. The general solution is log of modulus of y minus 1 equal to x squared by 2 plus c. X squared by 2. 1 by 2 means 0.5. 0.5 is given only in option C. Therefore, option C is correct without verification. So B is also wrong. So it is a 2 marks gate question of EC branch. Recent year question, 2020 gate question. The gate question, 2020 question, 2 marks problem. Right? Like this, you will find only simple questions like this from the differential equation topic. You will not find any difficult questions only. From the differential equation part, you will find only simple direct questions, no twisting questions only. All are simple questions only. Still, if you have any doubts, you can ask after 2 o'clock, 2 to 2:30. Sorry, not 2 o'clock, 4 o'clock. After 4 o'clock, I will take the doubt session after 4 o'clock up to 4:30 on. Okay. Now we go to the next problem. Problem number 4. The solution of the differential equation. I will send the today's class PDF format and at the end of the class. Don't worry. Have you received the yesterday's and day before yesterday class PDF? The solution of the differential equation dy by dx plus y equal to 1 with y equal to 0 at x equal to 0 is option A, y of x equal to e power x minus 1. Option B, y of x equal to 1 plus e power minus x. Option C, y of x equal to 1 minus e power x. Option D, y of x equal to 1 minus e power minus x. It is also 2 marks gate question. Just look at this problem and observe the problem. Compare this problem with the previous 3 problems and find out the difference. What is the difference between first 3 and this problem? Tell me the difference. If we have not received the first day, second day class PDF, again we will resend it. We will get it tomorrow or today evening. Don't worry about that. That's the last 2 days class. Now tell me what is the difference between this 4th problem and the previous 3 problems? Okay, I tell this. In the first problem, just differential equation was given without any condition. So that is a differential equation only, not an initial value problem. In the second problem also, just differential equation was given. It was asked to write the solution or general solution, not an initial value problem. In the third problem also, that is in the recent year 2020 gate question of EC branch 2 marks problem. The third problem also, just differential equation was given. But in this problem, in the fourth problem, differential equation is given along with the condition. Differential equation is given along with the condition. So it is an initial value problem only. If it is an initial value problem, you have to find the particular solution also. No condition, just differential equation is given, we stop with the general solution. Condition is given, you have to solve the problem up to particular solution. And options were given. Whenever options are given like this, and also it is, if it is an initial value problem, without solving the problem also, we can choose the answer, if possible. Always may not be possible. By verification, if it is possible to choose the answer, we can choose. Using the condition, if it is possible to choose answer, we can choose. So we try to choose answer by verification method using condition. Verification method. Method 1 is a verification method. Verification method. And we have 2 types of verification methods. One is using condition, other one is using the differential equation. Using differential equation, we can choose answer. Using condition, we can choose answer. Let us verify the options using the conditions only. Now we start with the first option, option A. What is the condition here? Y equal to 0 at x equal to 0. In every option, we substitute x equal to 0. In every option, we substitute x equal to 0. And we check Any one option gives y equal to 0 or not. First option is y of x equal to e power x minus 1. If you substitute x equal to 0 in this, y of 0 equal to e power 0 minus 1, 1 minus 1, 0. First option is satisfied. The condition is satisfied with the first option. So the first option may be solution. Maybe solution. We cannot say guarantee. No other option satisfied, then first option will be correct answer. More than one option also satisfied, we cannot choose answer. So first option may be answer. Next, we go to the second option. Y of x equal to 1 plus e power minus x. When you substitute x equal to 0, 1 plus e power 0, 1 plus 1, 2. From second option, we are getting y equal to 2, y of 0 equal to 2, but our y of 0 is 0. So second option is not satisfied with the condition. So B is wrong answer. Option C, y of x equal to 1 minus e power x. From this, y of 0 equal to 1 minus e power 0, 1 minus 1, 0. Third option is also satisfied. First option was satisfied. Third option is satisfied. So we cannot choose answer. Let us verify last option also. Y of x equal to 1 minus e power minus x. If you substitute 0 in place of x, this becomes 1 minus e power 0 equal to 0. So here, 3 were satisfied. Option A, C, and D. 3 options are satisfied with the condition. So we cannot choose answer by this verification method. Then we go to the next verification method on that. Next verification method. Method 2. Verification method only. In verification method, we have two methods. One is using condition, we can choose answer by verification, or using differential equation, we can choose answer by verification only. So using differential equation, if it is possible to choose, we can choose. Let us start with the first option, option A. Using differential equation, choosing the answer means just we check LHS equal to RHS or not. LHS of the differential equation is equal to RHS of the differential equation or not. Let us consider LHS. LHS of the differential equation is dy by dx plus y equal to. From the first option, y is e power x minus 1. So d by dx of e power x minus 1 plus, in place of y, e power x minus 1 equal to. Derivative of this is e power x minus 0 plus e power x minus 1 equal to 2 e power x minus 1. And this is not equal to RHS equal to 1. This is not equal to RHS of the differential equation 1. So the first option is not satisfied with the differential equation. So A is wrong. B is already wrong with the condition. Now let us go to the option C. LHS dy by dx plus y. That is first derivative of the option C is 0 minus e power x plus the same function 1 minus e power x. This is equal to 1 minus 2 e power x. So third option is also not satisfied. The differential equation is not satisfied with option C also. So first three are wrong means last must be correct. Last answer is correct. Or we can verify this. Option D, LHS equal to dy by dx plus y equal to derivative of the last option is 0 minus e power minus x plus y is 1 minus e power minus x. This is equal to minus, sorry, this is minus minus plus. So these two get cancelled. This is equal to 1. This is same as the RHS. So LHS is equal to RHS. The option D, satisfied with the differential equation. Therefore, D is the correct answer. Like this, without doing the problem also, we can choose answer by verification. So verification also, in verification also, there are two methods. Using initial condition, we can choose answer by verification, or using differential equation, we can choose answer. So whenever differential equation is given along with the condition and options are given, try to choose answer like this. This is a simple method. It is a 2 marks gate question. It is also 2 marks gate question. It is a 2 marks gate question. So we have done 4 problems out of 4. Last 2 are gate questions. The last 2 are, that is, we have done 2 problems today. These 2 are 2 marks gate questions. Right. So with this, the first method is completed. Out of 6 method, very first method is very important. And also you'll find like this simple questions for 1 mark or 2 marks. This first method is completed. Next we go to the second method. The second method is homogeneous method. Method 2. Homogeneous method. Already I told you that for every method there is some condition. That condition satisfies, we apply the particular method only for writing the solution of the differential equation. Before going to write the condition of this homogeneous method, we'll discuss about homogeneous function. Because for writing the condition of the homogeneous method, we require the condition of the homogeneous function. Condition of the homogeneous function. So let us start with the homogeneous function. After discussion of homogeneous function, we'll discuss about homogeneous method. Now first write the definition or condition of the homogeneous function. If f of kx comma ky equal to k power n into f of x comma y. For a function of two independent variables, x and y, for a function of two independent variables x and y, then the function f of x comma y is said to be a homogeneous function with degree n in x and y. If you are given some function of two independent variables x and y, and if you want to check the function is homogeneous or not, you have to verify this condition on. The condition is f of kx comma ky equal to k power n into f of x comma y. Here n is any number. This n is any number. That may be integer or a negative number or fraction or negative fraction, any number only. That doesn't matter. For example, f of x comma y equal to x power 4 plus y power 4 divided by x power 3 by 2 plus y power 3 by 2. Now here I wrote some function of two variables. We check whether it is homogeneous function or not. To check whether it is homogeneous function or not, we check the condition only. So to verify the condition of the homogeneous function, consider f of kx comma ky. In the function f of x comma y, replace x by kx, y by ky, and check whether it is written as k power something into same function or not. Kx power 4 plus ky power 4 divided by kx power 3 by 2 plus ky power 3 by 2. This is equal to, in the numerator k power 4 is common, into x power 4 plus y power 4 divided by, in the denominator also k power 3 by 2 is common, into x power 3 by 2 plus y power 3 by 2. This is equal to k power 4 minus 3 by 2 into the same function x power 4 plus y power 4 divided by x power 3 by 2 plus y power 3 by 2, which implies f of kx comma ky equal to, what is the value of this power? 4 minus 3 by 2. K power 5 by 2 into f of x comma y. Right, your answer is correct. 5 by 2 is correct. So finally, this condition of the homogeneous function was satisfied for this function. So it is a homogeneous function with a degree 5 by 2 only. Therefore, f of x comma y is a homogeneous function with degree n equal to 5 by 2 in x and y. It is also useful for calculus. In the calculus, one of the subtopic is partial derivatives. In that partial derivative, for Euler's theorem, we require this homogeneous function. So it is not only for differential equation, it is also useful for calculus also. So remember this homogeneous function condition. But whatever I wrote here function, it is a algebraic function only, not a transcendental function. This function of x comma y is free from all the transcendental functions only. Let us go to the next example, example number 2. In that example, let us consider the transcendental function. Don't take screenshot. I will share this PDF file. So we go to next page. Example number 2. F of x comma y equal to e power x plus y. It is a function of two variables, and also it is an exponential function. So it is a transcendental function. To check whether it is homogeneous or not, we verify the condition. For verifying the condition, let us consider f of kx comma ky equal to, replace x with kx, y with ky. E power kx plus ky equal to e power k into x plus y. Are you able to write the this exponential e power k into x plus y equal to k power something into e power x plus y. Is it possible or not? Check it on. If you are able to write like this, then we can set homogeneous function. If you are unable to write this, then it is not a homogeneous function. Now tell me. Waiting for answer. The degree of the homogeneous function may be any number that may be integer or non-integer or a fraction or negative fraction, any number. That's all. Doesn't matter. Whatever the number, doesn't matter. So here we cannot write this exponential function equal to k power something into same function. That is why it is not a homogeneous function. This is not equal to k power something into the same function f of x comma y. That is why it is not a homogeneous function. Therefore, f of x comma y is not a homogeneous function. Now, without checking this condition for transcendental functions, directly also we can set homogeneous or not without checking this also. I write that condition here, note point. Or before writing that note point, let us consider another example. F of x comma y equal to cos of x square plus y square divided by xy plus y square. It is one of the transcendental function, cos. It is a function of two variables. So to check whether it is homogeneous or not, again we verify same condition. Consider f of kx comma ky equal to cos of kx square plus ky square divided by kx into ky plus ky square. This is equal to cos of. In the numerator, k square is common. In the denominator also, k square is found common. So after cancelling the k square, this becomes just x square plus y square divided by xy plus y square. It is a function. Are you able to write this equal to k power something into the same function? Now tell me, is it possible to write this? Yes, many of them are saying yes, yes. Degree 0, right? Now here there is no k, so there is no k means that is 1. I am writing the k power 0 into the same function f of x comma y. K is not there, so in place of k we have 1, cos into 1 is written as k power 0 like this. So finally it is equal to f of kx comma ky equal to k power 0 into f of x comma y. Therefore, the function f of x comma y is a homogeneous function with a degree 0. Now, without checking this condition using the condition of the homogeneous, also directly we can set homogeneous or not, just by observation also. Now, I'll tell you that condition. Look at this function. Look at both functions. Example number 2, example number 3, both are transcendental functions. In example number 2, the function is e power x plus y. The example number 3, the function is cos of x square plus y square divided by xy plus y square only. For this transcendental function, this is the inner function. For this cos function, this is the inner function. Depending on inner function, we can say directly whether it is homogeneous or not. Inner function is algebraic function, like example number 1 only. Let us consider the example number 3, that is cos function. Here it is just like cos of some function g of x comma y. Cos of g of x on some function g of x. G of x comma y is this function. And check the g of x comma y is homogeneous function with the degree 0 or not. For cos function, inner function is g of x comma y. That g of x comma y is homogeneous function with the degree 0 or not. Check it out. Now tell me the answer. Yes. Yes. Right. Many of them are saying yes, right? For cos function, inner function x square plus y square by xy plus y square is algebraic function, and that algebraic function is a homogeneous function with the degree 0. That is why it is a homogeneous function with the degree 0 only. Now let us go to the example number 2, exponential function e power x plus y. In the function e power x plus y is a algebraic function. Just like this, if you compare this e power g of x comma y, e power g of x comma y. Now check this g of x comma y is homogeneous function with the degree 0 or not. In the example number 2, inner function g of x comma y is homogeneous or not. Check it out. Yes. Degree 1. Yes. No, sir. Degree 1. Not. Okay. I'll tell you. In the function f of x comma y equal to e power x plus y, the inner function g of x comma y is x plus y. That is, x plus y is a homogeneous function with the degree 1. For example 2, inner function is homogeneous function with the degree 1. In the example number 3, inner function is homogeneous function with the degree 0. Just observe these two only. Now I am telling the point. Remember this point. For any transcendental function, inner function is homogeneous function with the degree 0. For any transcendental function, inner function is homogeneous function with the degree 0. Then the main function is homogeneous function with the degree 0. That's all. For every transcendental function, inner function is homogeneous function with the degree 0. Then such a transcendental function is homogeneous function with the degree 0. Otherwise, that is not a homogeneous function. That's all. That is the second example is not a homogeneous function. Third example is homogeneous one. In the second example, inner function is homogeneous function with the degree 1. That is why exponential is not a homogeneous function. In the third example, inner function is homogeneous function with the degree 0. That is why cos function is homogeneous function with the degree 0. Remember this point. For any transcendental function, inner function is homogeneous function with the degree 0. Then only that transcendental function will be homogeneous function with the degree 0. Otherwise, not homogeneous function. So this is about homogeneous function. I'm writing the one note point on this homogeneous function. If f of x comma y is a homogeneous function, the short form of homogeneous function is h dot fun. Fun is the short form of function. First 3 letters of function is fun. Instead of writing the function always, I use the short form fun, fun. H dot fun is the homogeneous function short form. So f of x comma is a homogeneous function with the degree n in x and y. Then f of x comma y equal to, that is, we can write this f of x comma y in 2 ways, like this: x power n into phi of x by phi of y by x. y power n into phi of x by y. Suppose the function is homogeneous function. That function can be written in the form of function of y by x or function of x by y only. So function of y by x into x power n, function of x by y into y power n only. Every homogeneous function with any degree can be written in the form of like this or like this only. In two ways we can write as a function of y by x or function of x by y into x power degree, y power degree. So this is about homogeneous function. Now we write the second method, homogeneous method, condition only. So we are going to next page. Now I am writing the condition of the homogeneous method. If f of x comma y is a homogeneous function with degree 0, in a differential equation dy by dx equal to f of x comma y. If f of x comma y is a homogeneous function with a degree 0 in a differential equation, then the differential equation can be reduced to variable separable form by substitution. Y by x equal to v or x by y equal to v. It is a condition of the homogeneous method. So this condition satisfies, then we can solve the problem by homogeneous method or indirectly variable separable method. In the differential equation dy by dx equal to f of x comma y, and this f of x comma y is not in variable separable form, then we check whether it is a homogeneous function with the degree 0 or not. This f of x comma y is homogeneous function with the degree 0, then we can reduce this function f of x comma y to variable separable form only, so that we can solve the problem by variable separable method only. The reason for this is like this. Before this condition, in the previous page, we have written the note point. Every homogeneous function can be written in the form of function of y by x. X power n into function of y by x. Y power n into function of x by y. If this is a homogeneous function with a degree n, this can be written as like this one. Suppose degree 0. If it is a homogeneous function with a degree 0, then x power 0 into function of y by x. Y power 0 into function of y by x. Something power 0 is 1. So here this x power 0 becomes 1. Y power 0 becomes 1. So f of x comma y is directly function of y by x, function of x by y. In this function of y by x, if you replace y by x with some other variable, this function will be phi of v, single variable function. Again, if you replace x by y with a v, this function becomes x by function of v only. That is why we are replacing y by x with a v or x by y with a v to make the f of x comma y as separable form. But always the differential equation may not be in the form of dy by dx equal to f of x comma y. Sometimes this equation may be in the form of differential form, that is mdx plus ndy form also. For that also we have the same condition. That as a note point. If m of x comma y and n of x comma y are same degree homogeneous functions, same degree homogeneous functions, same degree homogeneous functions in a differential equation m dx plus n dy equal to 0. Then the differential equation can be reduced to variable separable form by substitution y by x equal to v or x by y equal to v. Both are same only. One is in derivative form, one is in differential form only. Because here we can add the m dx plus n dy equal to 0 if and only if m dx equal to minus n dy, if and only if dy by dx equal to minus m by n. That's for both same only. After adding the m dx plus n dy equal to 0 like this, dy by dx equal to minus m by n. In this m by n, both m, n are same degree homogeneous function. Then m by n will be homogeneous function with the degree 0 only. That is why same condition for both. That's all. This is about the condition of the homogeneous method. Now let us go to the problem on this. So we are going to next page. Problem number 1. The general solution of a differential equation x square plus xy plus y square dx minus x square dy equal to 0 is. This is the question. Now all of you observe the question and check whether it is a first order first degree or not. If it is a first order first degree, is it in variable separable form or not? Check it out. Is it variable separable form or not? Check it. The differential equation is in the form of one of the general form, differential form. Here, m dx plus n dy form equal to 0. It is another general form, m dx plus n dy form. In both m and n, The variables are separable. Then only we can solve this problem by variable separable. Otherwise, we cannot solve. Here, n equal to just a function x square. It is purely function of x. Function of y is 1. In function n, variables are separable. Here, minus x square. In m function is x square plus xy plus y square. In this function m, we cannot write the function of x into function of y. So this is not in variable separable form. This is in variable separable. So finally, we cannot solve this problem by variable separable. We cannot solve this problem by variable separable. Then you have to go for next method condition. After first method, next method is homogeneous method. What is the condition of the homogeneous method? Just now we have written the condition of the homogeneous method. Suppose the differential equation is like this: dy by dx equal to f of x comma y. Then this function should be homogeneous function with the degree 0. Or the equation is like this: mdx plus mdy equal to 0. Then these two should be same degree homogeneous functions. Now check whether m and n are same degree homogeneous or not. In place of m, we have algebraic function. In place of n also we have algebraic function. If it is algebraic function, in easy way we can check whether it is homogeneous or not. That to here, only numerator term is present, no denominator. Note, it is not a fraction. M is not a fraction, n is not fraction only. In every term, the powers are same. In x square term, the power of x is 2. In y square term, power of y is 2. In the middle term, xy, the sum of the products, the sum of the variables for this product. Whenever you have a product of variables, whenever we have a product of variables like this, xy, we have to observe the sum of their powers. The power of x is 1, power of y is 1. Sum of the product, sum of the powers of these two products. Sum of the powers of these two is 1 plus 1 equal to 1. Power of x is 1, power of y is 1. And for this product, sum of the powers is 2. X square plus xy plus y square. In this total function, in every term, the sum of the powers of the variables is same. Therefore, it is a homogeneous function with the degree 2. In place of n also, it is a homogeneous function with the degree 2 only. M, n are same degree homogeneous functions. That is why we can solve this problem by homogeneous method, but indirectly variable separable. Let us solve this problem. Given differential equation is x square plus xy plus y square dx minus, or we can have the plus minus x square minus x square dy equal to 0. So this 1. Since it is in the form of m dx plus n dy equal to 0 only. We read the another general form, derivative form, dy by dx equal to. We shift the second term other side and we do the cross multiplication so that we can have the dy by dx equal to dy by dx equal to x square plus xy plus y square divided by x square. This is in the form of dy by dx equal to f of x comma y. Since it is in the form of dy by dx equal to f of x comma y form. Now check the homogeneous method condition for this also. Numerator is a homogeneous function with the degree 2, denominator is a homogeneous function with the degree 2, 2 minus 2, 0. That is why we can solve this by homogeneous method or indirectly variable separable. This f of x comma y is not in variable separable form, but we can reduce the f of x comma y into variable separable form. That is why we can solve it by variable separable indirectly only. To reduce this two variables available form, we have a substitution. Let y by x equal to v. We can take y by x equal to v, or we can take x by y equal to v. Any one we can choose. Whatever you choose, you get answer on. But generally we choose like this only. Suppose the equation is dy by dx equal to f of x comma y, then take the y by x equal to v. Or if the equation is dx by dy equal to f of x comma y, then take the x by y equal to v on. Or you can take any one, no problem. Now I am taking the y by x equal to v. So we are introducing some new variable v. Whenever we introduce some new variable like this, then you have to change dy by dx in the equation. To change the dy by dx in the equation 2, you have to find the dy by x term from the equation 3 only. Or we can write the equation 3 like this other way also. Or y equal to vx. So this 3. Then when you differentiate this on both sides with respect to x, so that we get the dy by dx. On left hand side dy by dx, on right hand side vx. It is a product of two functions. Then use the product rule. What is the product rule? dy by dx of uv equal to u into dv by dx plus v into du by dx. So v into x derivative with respect to x1 plus x into v with respect to x is dv by dx. So this is 4. Substitute these two in equation 2 on. Or using 3 and 4, 2 becomes, in place of derivative at the v plus x into dv by dx. On the right hand side, wherever y is there, in place of y, write vx, x square plus x into vx plus y square means v square x square divided by x square. On right hand side, from every term x square is common. From each and every term x square is common. So after simplification, v plus x into dv by dx equal to, after cancelling the x square term on right hand side, we'll have like this 1 plus v square. On both sides we have the same term with the same sign v. These two get cancelled. After cancellation, right hand side will be only function of v, left hand side only function of x. So variables are separable. So which implies after rearrangement, get the integral of 1 by 1 plus v square dv, integral of 1 by x dx plus c. This gives our general solution. For left hand side is in the form of integral of 1 by a square plus x square, or 1 plus x square. A square plus x square form, or 1 plus x square. If it is integral of 1 by a square plus x square, then 1 by a tan inverse of x by a. If it is 1 by 1 plus x square means tan inverse. Tan inverse of v equal to other side log x plus c. But v is, what is a v? Y by x. Therefore, tan inverse of y by x equal to log x plus c is a general solution of 1. The problem is completed. For logarithmic function, we write in two ways, log and ln. This is the common logarithm. Log means common logarithm. Ln means natural logarithm only. When you write the ln means base is always e. But instead of writing the ln, Instead of writing the ln, always we write the log log only. But here base is not mentioned. Whenever base is not mentioned for log, then it is understood that ln only. It is understood the base is e, it is ln only. Both are logarithmic functions. One is log, other one is ln. Ln means natural logarithm and log means common logarithm only. Instead of writing ln always, we write the log without any base. Log, I did not write any base. If you do not write base means that is understood that base is e only. Suppose if I write the log of something to the base 10, that is, it is a common logarithm one. Now, in general, we use the common logarithm log, the calculations only. For theoretical, we use the natural logarithm ln, that is base e only. So this is about the solution of this problem. Now we write the another problem. So we are going to next page. Problem number 2. The general solution of dy by dx equal to y by x plus secant of y by x is. Now it is a question, dy by dx equal to y by x plus secant of y by x. By looking this question or by looking this equation, we can say it is a first order first degree differential equation. That it is in derivative form. Dy by dx equal to function of x and y only. Because of this, we start with the very first method, variable subvariable only, and check the condition of the variable submethod. The condition of the variable subvariable satisfies or not, check it only. Satisfies, we can solve the problem by variable subvariable only, because that is very simple method. In the doubt session, I clarify your homogeneous function degree doubt in the doubt session after 4 o'clock, 4 to 4:30. Is it in variable subvariable form? Not in variable subvariable form. On right hand side, f of x comma y is not in the form of variable subvariable form. Not in the form of variable subvariable form. So we cannot solve this problem by variable subvariable method. Because here this function f of x comma y is not written in the form of h of x into g of y. The first method condition fails, then we go to second method. Second method is homogeneous method. According to second method, it should be a homogeneous function with the degree 0 only. Is it a homogeneous function with the degree 0 or not? We have two functions. One is y by x, other one is secant. Y by x is algebraic function, secant is transcendental function. If you replace x with a kx, y with a ky, this will be ky by kx plus secant of ky by kx. So kk get cancelled, y by x plus the secant function also kk get cancelled, y by x. So this is same as the function f of x comma y. F of kx ky equal to f of kx comma ky equal to 1. This is the function f of x comma y. So f of kx comma ky equal to f of x comma y. But into we require the k power something. K is not there. So we can have the k power 0. So it is a homogeneous function with the degree 0. That is why we can solve this by variable separable method indirectly after reducing this function to variable separable form. To make it separable form, the substitution is y by x equal to v or x by y equal to v. Or this equation is directly in the form of like this only. dy by dx equal to f of x comma y, and this function is already in the form of function of y by x directly. If you observe the function, total function, in place of variable, directly we have y by x. That is why it is a function of y by x. So whenever dy by dx equal to function of y by x, directly replace y by x with v, so that we get single variable function. Let us do this problem in the solution. First, write the given differential equation. Dy by dx equal to y by x plus secant of y by x. So this one. Let y by x equal to v or y equal to vx. So this 2 on. Then dy by dx equal to v plus x into dv by dx. So this 3 on. Using 2 and 3, 1 becomes, in place of derivative, write the v plus x into dv by dx. On right hand side, v plus secant v on. Again, both sides we have same term with the same sign, v. So both will get cancelled. After cancellation, right hand side will be only function of v, left hand side will be only function of x. So variables are separable. Integral of 1 by secant v dv equal to integral of 1 by x dx plus c. Or other way we write the 1 by secant means cos v dv equal to log x plus c. Integral of cos is sine. Therefore, sine of v. But v is y by x. So sine of y by x equal to log x plus c is a general solution of equation 1. So it is other problem for homogeneous method. So if the differential equation is in the form of dy by dx equal to f of x comma y, then check the function f of x comma y is variable separable form or not. If f of x comma y is in the form of variable separable, then solve by directly variable separable method. If the function f of x comma y is not in the form of variable separable, then check the function f of x comma y is a homogeneous function with the degree 0 or not. With the degree 0, we can solve this also indirectly by variable separable like this, by making the f of x comma y to variable separable form. So this is about homogeneous method. Let us go to the next page. Now till now we have seen the two methods. One is variable separable, other one is homogeneous method. Next we go to the other method. So before writing the method, let us look at this. Here I wrote one of the general form of the first order first degree differential equation, that is differential form. On left hand side we have the sum of the two terms. It is one term, it is one term. On left hand side we have a sum of the two terms. if you are able to write the two terms as a single term like this, d of u of x comma y equal to 0. If you are able to write the m dx plus n dy as a like this differential of some function, then we can say it is a exact differential of this function. If we can write the sum of the two terms as a single term like this, then this is the exact differential of this function. Equal to 0 equation. So this is the exact differential equation. If you are able to write the two terms as a single term, then this equation is called exact differential equation. If it is exact, directly write the solution u of x comma y equal to c. For example, x dy plus y dx equal to 0. This is one term, this is one term. Now check whether you are able to write or not, whether you are able to write the two terms as a single term or not. Before this, let us look at the derivative formula. D by dx of uv, derivative of product of two functions, u into dv by dx plus v into du by dx. Derivative of product of two functions or differential quotient of product of two functions. Like this, d of uv equal to. Now, what is the difference between these two? The first one is derivative, second one is differential. Derivative means change in one quantity corresponding to change in other quantity. Differential means change in only one quantity, that's all. In the above formula, if you remove the denominators, we get the same formula for this also. That is just like above, first function into change in second function plus second function into change in first function. That's just like above. Without this, that becomes like this. So first one is a derivative or a differential quotient. Second one is differential. Now these two terms are in the form of like this. That is why in place of these two terms, we write the d of xy equal to 0 only. So if you are able to write the two terms as a single term like this, then this sum is the exact differential of this function xy. Because of the equation, this is the exact differential equation. If you are able to write like this, then directly write the solution xy equal to c is the general solution. But for every exact differential equation, writing the two terms as a single term is not an easy. Here, if we have a simple functions m, n, then in easy way we can write it. If we have a complicated function, writing the two as a single term is not an easy. That is why in such case, we verify some condition. The condition is like this: m with respect to x, n with respect to y. M with respect to m dx plus n dy equal to 0. M with respect to y equal to n with respect to x. That is dou m by dou y equal to dou n by dou x. We verify this condition. This condition satisfies, then this is a exact. If it is exact, we have a shortcut formula to write its general solution. Instead of going for general method, we use the shortcut formula. According to that shortcut formula, we do like this. We integrate m with respect to x. By treating other variable y as constant. We integrate n with respect to y when it is free from variable x. Suppose n function is like this: x plus y, n equal to x, n equal to xy plus y square plus 2, like this one. N may be a single term, or n may be sum of two terms, n may be sum of more than two terms, like this one. Out of all the terms, if any term is free from variable x, the term doesn't contain x, then we can choose that. If a term contains x, eliminate the term. This is a term free from variable x, we can choose this. It is a term without x, we can choose this. It is a term with x, so we never choose this, like this. So consider the terms without x and integrate with respect to y. That's all. It is a simple method only. Just integrate m with respect to x by treating y as constant. Integrate the terms without x with respect to y. Add both. That will give the solution. So this is about exact differential equation method. After variable separable, next important is exact, and the next simple method is also exact. So out of 6 methods, 1, 3, 5 are very, very important. Out of 3 important, first one is very, 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 very important, because most of the questions from first order first degree on variable separable, and that method is very simple. Let us go to the next page. Till now we have completed the 2 methods. We are going to start the next third method. The name of the method is exact. Method 3. Name of the method is exact method. First, study the definition of exact differential equation. Exact differential equation. If a differential equation of the form m dx plus n dy equal to 0 is written as d of u of x comma y equal to 0 for some function u of x comma y, then the differential equation m dx plus n dy equal to 0 is called an exact differential equation. If we can add the left part as d of some function, then that is exact differential, and equal to 0 means exact equation. Example, x dy plus y dx equal to 0, which implies d of xy equal to 0. Therefore, xy equal to c is a general solution, and this is the exact differential equation. Exact differential equation short form is EDE. Next, we are the condition of the exact differential equation. That is the second one. Condition of the method. The condition of an exactness of an exact differential equation m dx plus n dy equal to 0 is dou m by dou y equal to dou n by dou x. It's a condition for exactness of exact differential equation. For a given m dx plus n dy equal to 0, this condition satisfies. We can say that is exact. If it is exact, we can add the solution by our shortcut method. Here we have written the exact differential equation definition and the condition of the method. Then we go to the next point, third point. That is, third point is, in third point we read the general solution shortcut method. General solution. The general solution of an exact differential equation m dx, or we write this as m of x comma y dx plus n of x comma y dy equal to 0 is given by the general solution of an exact differential equation m dx plus n dy is given by integral sign, inside the integral sign, m of x comma y dx plus integral of, before writing the sum function inside this, let us come to the first integral sign. Under the first integral sign, write the like this, treating y as constant. Now inside the second integral sign, we write like this, consider the terms without x in n of x comma y dy equal to c. This is a direct format to write the general solution of exact differential equation when the exactness condition satisfies. This is about exact method. Now we move on to the problems. In the next page, we write the problem on this method. The solution of the differential equation x square into dy by dx plus 2xy minus x plus 1 equal to 0 is option A, 1 by 2 minus 1 by x plus 1 by 2x square. Option B, 1 by 2 plus 1 by x minus 1 by 3x square. Option C, 1 by 2 plus 1 by x plus 1 by 2x square. Option D, minus 1 by 2 plus 1 by x minus 1 by 2x square. It is a question. Also, I wrote 4 options. If you observe all the options, you can find one difference. The observation from all the options is no arbitrary constant. That is, in every option, particular solution was given for the differential equation. Let us do this problem. The differential equation is not in the standard form of the first order first degree only. We have two general forms or standard forms of the first order first degree. One of the general form is dy by dx equal to f of x comma y. Other general form or standard form is m dx plus n dy equal to 0. If we can get the given equation in any one of these, we can verify the conditions of the method. Okay, let us write this equation in form of m dx plus n dy equal to 0. Given 2xy minus x plus 1 into dx plus x square into dy equal to 0. So this 1. Since it is in the form of m dx plus n dy equal to 0. So it is one of the first order first degree differential equation. And that it is in the form of m dx plus n dy equal to 0. If it is a first order first degree, always we should start with a first method condition. In place of m, variables are separable or not, check it on. In place of n also, variables are separable and check it on. N function is in the form of variable separable form, but m is not in the form of variable separable only. In n, we can separate variables. In m, we cannot separate variables. So we cannot solve this problem by variable separable method. Whenever a variable separable method condition fails, then we try to check the condition of second method. According to second method, the condition is, the equation is like this. This function should be homogeneous function with degree 0. Or if the equation is like this, these two functions, m and n, should be same degree homogeneous functions. We check whether these two same degree homogeneous or not. N equal to x square. Single term is always homogeneous. It is a function with the degree 2 on. But m equal to 2xy minus x plus 1. In the first term, we have a product of two variables. If we have a product of two variables, then observe the sum of the powers. 1 plus 1, 2. From the first term, the power of the variables is 2. In the second term, power of the variable is 1. In the third term, no variable, its power is 0. In all terms, the powers are not same. Therefore, it is not a homogeneous function. M is not a homogeneous function. N is homogeneous function. When m, n are both, when m, n are homogeneous functions, same degree, then only we can solve this by homogeneous method. That is indirectly variable. But here, m is not a homogeneous function. N is homogeneous function. Because of this non-homogeneous function m, we cannot solve this by second method also. So we cannot solve this given problem by first two methods. Then we go to the next method. Next method is exact. The condition of the exactness of the differential equation satisfied. On check it out. Which implies m equal to 2xy minus x plus 1 and n equal to x square. Which implies find the derivatives. Dou m by dou y equal to partial derivative dou m by dou. That is, differentiate m partially with respect to variable y. While differentiating the function partially with respect to one variable, we consider other variable as constant. So we are doing with respect to y, then x is constant. 2x, x derivative 0, 1 derivative 0. Dou m by dou y is 2x. And dou n by dou x equal to 2x. Are these two same or not? Check it only. Here these two are same. Here dou m by dou y equal to dou n by dou x. The exactness condition of the exact differential equation is satisfied for the given equation. Therefore, the given equation is exact differential equation. Therefore, the given differential equation 1 is an exact. So we cannot solve this problem by first two methods, but we can solve this by exact. According to exact method, directly we write the solution in easy way using shortcut method. Now the general solution of 1 is given by integral of m. M function is 2xy minus x plus 1 dx plus from function n. Here n equal to x square. N is containing only single term, that too with a variable x. So ignore this. Ignore this. That is 0. dy equal to c, which implies 2x square by 2y minus x square by 2 plus x equal to c. It is a general solution. Therefore, x square y minus x square by 2 plus x equal to c is a general solution. But this solution was not given in the options. It is a general solution because of the c arbitrary constant. In every option, particular solution was given, that to y equal to some function of x form. So here to write the y in terms of x, shift all the terms other side and write the y on left hand side. So or y equal to, keep the x square y on left hand side, shift the all other terms other side only. So minus x square by 2 becomes plus x square by 2. And then divide the x square. Divide with x square. So that we get the y only. To get only y, we divide with x square and then shift all other terms other side only. So minus x square by 2 divided by x square becomes just 1 by 2. Next, plus x by x square, that becomes 1 by x. That plus becomes here minus 1 by x. Next, c plus c. Divided by x square means x. So this solution was given in the options. In every option, check plus 1 by 2 is there or not. In the first option, plus 1 by 2 is there. Second option, plus 1 by 2 is there. Third option, plus 1 by 2 is there. In the last option, minus 1 by 2 is there. So we cannot choose the option because in more than one option, plus 1 by 2 is there. And the last option is wrong. Next, minus 1 by x is present or not. In first option, minus 1 by x is there. In the second option, plus 1 by x. In third option, plus 1 by x. So these two are wrong. Then answer is this. So option A is the one of the particular solution of the differential equation for c equal to 1 by 2 only. So if it is not possible to solve the problem by first two methods, then we try to check the exactness condition for the differential equation. Satisfies, this exactness condition satisfies, then do the problem by exact method. This is about exact method. Suppose dou m by dou y not equal to n by dou x, then that is not exact. Not exact means non-exact. This is about exact method. Then we are going to next page. Don't write, just look at this. I'm writing one differential equation. y dx minus x dy equal to 0. Just look at this problem and tell me the methods. Till now we have seen three methods. One is variable subvariable, next second one is homogeneous method, third one is exact method. Are you able to do this problem by three methods? Are able to do the problem by three methods, or only one or two? Already I told you that in the differential equation topic, whatever we discuss the methods, all the methods are analytical methods. Because of the analytical methods, one problem can be solved by only one method. One problem can be solved by more than one method. One problem cannot be solved by any method. One problem cannot be solved by any method. For every differential equation, we may or may not get solution because we have very few limited methods only. Method is available, we can add the solution. Method is not available, we cannot add the solution. So all differential equations cannot have a solution. If we have a method, we can find the solution of the equation. Now tell me the methods. Are able to solve this problem by first method, variable subvariable method. Only one method, or two methods, or three methods? Method one is possible or not? So everyone is saying that method one is possible. Yes, we can solve this by first method because only y, function of y, no function of x. Here only function of x, variables are subvariable. So we can do this problem by variable subvariable method. Next, can you do this problem by homogeneous method? Are you able to solve the problem by homogeneous method? Now tell me the answer. Most of them are saying yes, 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 right? You're saying you are correct. Because m equal to just y. Here m equal to y. Single term means it is a homogeneous function with the degree 1. N equal to x, it is a homogeneous function with the degree 1. Both are same degree. So we can solve this by homogeneous method also. Next, what about other method, third method? Can you solve this problem by third method? What about third method? Yes or no? Okay, let us check the first two methods are possible for this problem. We check the third method condition. Condition satisfies, we can solve this by exact. Otherwise, we cannot solve one. Now it is in the form of m dx plus n dy, or if you write the standard form, y into dx plus minus x into dy equal to 0. Since it is in the form of m dx plus n dy equal to 0. Here m with respect to y, that is dou m by dou y equal to 1. And for n, dou n by dou x equal to minus 1. These two are not same. Dou m by dou y. Its a short form is m suffix y. Dou n by dou x. Its a short form is n suffix x. Instead of writing the dou m by dou y, I try to write the m suffix y. Instead of writing the dou n by dou x, I try to write the n suffix x only. Here these two are not same, therefore it is not exact equation. That is why we cannot solve this by exact method. So from this we can say that we can solve this problem only by first two methods. We cannot solve this by third method. So whenever exactness condition fails, we cannot solve this by exact method only. Dou m by dou y is not equal to dou n by dou x, so it is not exact. Not exact is called non-exact equation. Not exact is non-exact equation. It is a non-exact equation only. non-exact differential equation. Here, I am multiplying one function with this equation on both sides. I am multiplying one function on both sides of this given equation. Like this, 1 by x square, 0, which implies y by x square dx plus minus 1 by x dy equal to 0. Now it is a new equation. Again, it is in the form of m dx plus n dy. This is new m, this is a new n. M with respect to y equal to 1 by x square, and here n with respect to x is minus 1 by x derivative is minus plus 1 by x square. So both are same. First of all, the equation was non-exact, but after multiplying 1 by x square, the equation is becoming the exact term. From this, we can set the non-exact can be made exact. Non-exact can be made exact after multiplying with one function. So here, this function 1 by x square is called integrating factor. If you are able to convert non-exact to exact by multiplying some function, then such a function is called integrating factor. Suppose if I multiply some other function like this, 1 by y square into y dx plus minus x dy into 1 equal to 1 by y square into 0. Again, this equation becomes 1 by y dx plus minus x by y dy equal to 0. New equation. New m, new n. For this, we verify the condition. M with respect to y equal to minus 1 by y square. N with respect to x equal to 1 by y is constant. So we are multiplying both sides with 1 by y square. Minus 1 by y square is constant. X derivative with respect to x is 1. So minus 1 by y square. Again, these two are same. Now exactness condition is satisfied. So it is a exact differential equation. Or if you multiply 1 by xy on both sides, y dx plus minus x dy equal to 1 by xy into 0. Again, the equation becomes 1 by x into dx plus minus 1 by y into dy equal to 0. M with respect to y equal to 0, n with respect to x equal to 0. Both are same, exactness condition is satisfied. So it is also integrating factor. Or if you multiply 1 by x square plus y square and so on like this also, the equation becomes exact. The non-exact can be made exact after multiplying some function. Such a function is called integrating factor. But every non-exact cannot be made exact. Every non-exact cannot be made exact. Remember this point. So for the given non-exact equation, integrating factor may or may not exist. For the given non-exact equation, integrating factor may or may not exist. Suppose integrating factor exists, more than one exists. Like this, 1 by x square, 1 by y square, 1 by xy, 1 by x square plus y square, 1 by x square minus y square, and so on, like this. From this, we can say that integrating factor may or may not exist more than one also exists. It is a condition. Right. So we start the next method. Next method is non-exact method. Till now we have completed 3 methods: variable, subvariable, homogeneous, and exact. we are going to start the next method, that is non-exact method. In the non-exact method, we try to write the methods of finding the integrating factors only. In the non-exact method, we write the methods of finding the integrating factors. Using this integrating factor, we can convert the non-exact to exact, non-exact to exact, and then we write the solution of the exact by exact method onwards. Right? Okay. With this, I close the session, and we continue this tomorrow. So after this, we can take break, and then I start the doubt session up to 4:30. So today's class is completed. Then we go to the, if we have any doubt, then we can ask now. If you don't have doubts, you can take the break. Today's session is completed. Okay, let us start the doubt session. Class is complete. We start the doubt session. Hello, hello. Hello.
Hello, good afternoon, sir.
Good afternoon. Tell me your doubt.
Sir, yes, sir. Sir, I had a doubt in the first of today. I think it is in 1F page.
First page.
Yes, sir.
Okay, I'm going to first page.
I think maybe next. The first problem of today, sir. The first problem.
Okay.
GATE 2020 EC.
Yeah, this one, third problem.
Sir, in problem, if we at y equals to 1, sir, if we take y equals to 1, then there will be log 0, no, sir. Log 0 value is undefined, no, sir. So when there was a, when there was a between.
Is you see this question? In every option, two solutions were given. One is with arbitrary constant.
Yes,
one is without arbitrary constant. So with arbitrary constants, one solution is general solution. Other one is particular solution. Okay. So both are solutions.
Particular. Yes, sir.
Solution means don't substitute y equal to 1 or minus 1 in the solution. Substitute the y equal to 1 minus 1 in the question, differential equation.
Oh.
Got it?
Oh, fine, sir. So, thank you. Yes, sir. Thank you.
Okay, right. Next. Hello, you can ask your doubt.
Hello, sir. Sir, good afternoon, sir.
Good afternoon.
Sir, I have a doubt in yesterday's one problem. Sir.
Which problem?
Sir, first problem of variable separable.
Okay. What is your doubt?
Sir, in that problem, sir, you have taken one integration of 1 upon under root a square plus x square in sine inverse h y. Sir, but that formula is
Wait,
not.
let me write. Tell me. dy by dx equal to x square plus y square plus 1 plus x square y square.
Yes, root of, yes, sir. Sir, in this one of.
Hello, voice is not clear.
Hello, sir.
And
Sir, in that some.
your voice is breaking.
Hello, sir.
Sir,
in that how another.
Not audible.
Hello, sir. Hello. Hello.
Hello.
Hello.
Tell me.
Hello. Yes, sir. Sir, in that 1 upon under root of 1 plus y square.
Yeah.
In
1 by under root of
y plus y.
a square plus x square formula. This
Sir,
is required.
another formula. So, sir, inverse. Okay, sir. Okay.
We can write anyone. Both are same. Here.
Yes.
Next, we go to next one. You can ask your doubt. Hello.
I had a doubt. You have given in the homogeneous method.
Homogeneous method. Okay.
And with an example. Yes, sir. In that fxy of the form xn dot phi into y by x.
Yeah.
Sir, can you give an example
for this?
X, the n equal to 0.
Okay. I will write down. For this, you want example.
Yes, sir.
If you want to write this
Zero,
form,
sir.
the function should be in the form of homogeneous function with some degree. Now I am taking the f of x comma y equal to, let us suppose x square plus xy plus y square. It is a homogeneous function with the degree 2 because in every term, the powers of the variable is same. In the first term, x power is 2. In the last term, y power is 2. In the second term, product of variables, there is sum is 2. In every term, power of the variables is same. So it is a homogeneous function with the degree 2 only. So if you want to write this function in the above form, then we can write this as x power 2 into function of y by x, or y power 2 into function of x by y. These two are possible only. Suppose if you want to write the x square into function of y by x square, from each and every term, we should take the x square as common only. If you take the x square outside, then the function becomes 1 plus xy by x square plus y square by x square. And this equal to x square into 1 plus y by x plus y by x square. This is equal to x square into function of y by x. Got it? Hello? In this function, every term,
I got it, sir.
Similarly, if you want to write the y square into something, take the y square as common so that we get function of x by y. Here?
Yes, sir. Sir, for transcendental.
Transcendental. For every transcendental function,
Hello.
Tell me. Suppose f of x comma y equal to
Yes,
some.
sir. For transcendental.
I am writing transcendental function. Let us consider some example. Cos of g of x comma y. Some function f of x comma y equal to cos of something. For this cos transcendental function, inner function is g of x comma y. For any transcendental function like this, g of x comma y is homogeneous function with the degree 0, then only the total function will be homogeneous function with the degree 0. Otherwise, not a homogeneous function. For example, f of x comma y equal to cos of x plus y divided by x square plus y square, like this. And if you consider condition f of kx ky equal to cos of kx plus ky divided by k square x square plus k square y square. This is equal to cos of k by k square x plus y.
Yes, sir. This one I answer. Hello. Hello.
Hello. Am I audible?
I was just, yes, sir. Yes, sir. Hello.
Let me write. Wait.
Sir.
1 by k into x plus y divided by x square plus y square. But this is not equal to k power something into cos of the same function x plus y by x square plus y square. Because cos of kx is not equal to k into cos of x. Got it? That is why we cannot write down. Suppose if it is like this.
Got it.
Okay, right. X square plus y square by x y plus y square. Every power is same. If we replace x with the kx, y with the ky, all k's will get cancelled. Then we can add the k power 0 into some cos function. That is why for every transcendental function, inner function should be homogeneous function with the degree 0 only.
Yes, sir. Yes.
Right. Okay, we'll go to another person.
Okay, sir. Thank you.
Welcome. You can ask question.
Hello, good evening, sir.
Good evening. Tell me.
Sir, today's third question, sir. Dy by dx plus y equal to 1.
Dy
So
by
in
dx.
that, sir, I was using variable separation method. So my answer came something different. I just need to kind of, if you could help me out in that part.
Oh, this one? You are
No,
talking
sir,
about
plus 1. Dy by dx plus y equal to 1. The next question.
Oh, wait. Your question is dy by dx equal to?
Dy by dx plus y equal to 1.
Dy by dx equal to?
Plus y equal
Plus
to 1.
y equal to 1. Okay.
Yes, sir. In that we have to take find the value at y equal to 0 and x equal to 0. That question.
Here, do you want solution for this?
Variable separation method, sir.
So on right hand side we have only 1 minus y. 1
Yes,
by
sir.
1 minus y dy equal to integral of 1 dx plus c only.
Yes.
And this is in the form 1 by x form, right? But not
Yes, sir.
1 by x. We have other function 1 minus y. So here we use this method, integral of f dash of x by f of x dx. This is equal to log of f of x. So what is the derivative of 1 minus y? With respect to y is minus 1. In the numerator, no minus 1. So we write the minus into log of 1 minus y equal to x plus c on. Or log of 1 minus y power minus 1 equal to x plus c on. right?
Yes, sir. Got it, sir. Got it, sir. Answer. Thank you very much, sir.
Next, we move to the other person. Okay, you can ask that your doubt. Hello,
Sir, I had a doubt in 14F page, sir.
14th page.
Sir, good evening, sir.
Good evening.
Sir, I had 14F, sir. 14F. I had a doubt in 14F.
Okay, I'm going to 14F. Right. Now,
Sir, here how to find out the value of C, sir?
don't find value of C. After writing our general solution, in every option, just this, in every option, there is no Y.
Yeah.
So we can say that is a solution was given like this only, Y equal to function of X form.
Okay.
That is why our solution here is Y in terms of X only.
Sir, in the second option, if in case they have given 1 by 2 minus 1 by X, sir, then, sir?
Like that, we cannot choose. So more than one option will be correct. Actually, it is a gate question. It is a gate question.
Okay, okay.
It is a gate question.
Okay, sir. Thank you, sir.
Okay.
Okay, sir.
Right. Next.
Hello, sir.
Hello. Tell me.
Sixth page, sir.
Which page? Sixth. Page number 6. Okay.
Sir, here in example 3, how degree is equal to 0, sir?
Actually, cos of some function, right? When you replace x with the kx, y with the ky, we are getting that just a function, cos function, cos of x square plus y square by xy plus y square. It is same as our given function, not?
Yes, sir.
So f of kx comma ky equal to cos function. Are you able to write this in the form of our main condition? F of kx, ky equal to k for something in f of x, y. Are you able to write or not?
Yes, sir.
Actually, cos into, we should have k power something only, but nothing is there. Only 1 is there. Because of 1, we cannot get k power 0.
Okay, like k's degree is that, sir? Like,
degree 0.
And actually, you said like without solving, we can directly...
without solving means just observe this only. Let us consider this cos function as cos of some function g of x, y. So inner function g of x, y is x square plus y square by xy plus y square, right?
Yes, sir.
Okay. This g of x, y is algebraic function.
Yes, sir.
That function is homogeneous function with a degree 0 or not, check it on. Like first example, okay? If you replace x with the kx, y with the ky, in the numerator, k square x square plus k square y square, in the denominator k square xy plus a k square y square. In every term, k square will get cancelled. So inner function is a homogeneous function with the degree 0. Correct?
Yes, sir. That is by procedure, sir. But by seeing you said directly, we can determine.
That's like this only. Without checking like this, just observe the okay. Other way. What is the numerator function here? X square plus y square.
Yes, sir.
Denominator function is xy plus y square.
Yes, sir.
Numerator is a homogeneous function with a degree 2, right?
Okay, sir.
Denominator is also homogeneous function with a degree 2.
Degree 2, yes.
Both are same degree or not?
Yes, sir.
Whenever numerator and denominators are same degree homogeneous functions, then that will be homogeneous function with the degree 0 only directly by observation.
Okay, sir. Like in example 2, sir, the degree of x and y are 1, 1, sir.
1, 1. But that is a homogeneous function with the degree 1, not degree 0. The whole function x plus y is homogeneous function with the degree 1, not degree 0. That is why exponential is not homogeneous function. In example number 3, x square plus y square divided by xy plus y square is homogeneous function with the degree 0.
Okay. Like if it is degree 0, then only it is homogeneous, sir.
Yeah. For transcendental functions. For every transcendental, you take any transcendental, log, tan inverse, cot, e power, log, anything, sin h of something. For every transcendental, inner is homogeneous function with a degree 0. Then main transcendental will be homogeneous function with a degree 0.
Okay, sir. But in the previous problem, the degree is not 0, sir.
Which one?
But it is homogeneous.
With which problem?
Fifth
one.
page.
And fifth one, it is an algebraic function.
Okay, that condition is valuable only for transcendental functions.
That is only for transcendental.
Okay, sir. Okay, got it, sir.
For the transcendental function, inner function is algebraic. For inner algebraic, we are using this method.
Okay. And sir, if in GATE exam, if they give one question, then we need to check all the 6 methods, sir.
No, just by after practicing all these, directly we can identify, we can tell the method on.
Okay, sir.
You get idea on by looking this function f of x, y.
Okay, because in some problems you said, in last problems what you have explained, it will be solved by all 3 methods.
Yeah.
No.
Last one, y dx minus x dy.
Yes, sir.
Then we can solve only by first 2 methods. We cannot solve that problem by exact.
But exact can be, non-exact can be done with exact.
Yeah. After conversion.
Okay, then it will be solved by exact also, right, sir?
Right, but not directly, indirectly.
Okay.
That is why we cannot solve by exact directly, but we can solve that non-exact by exact indirectly after multiplying function.
Okay, thank you, sir.
Okay, right. Now you can ask.
Hello.
Hello. Tell me.
Sir, I want to ask for how to determine the degree, sir, in homogeneous method, sir. For example, if we have dy by dx equal to f of xy, the degree should be decided by the differential, sir. How
degree should be degree should be defined by the function. Okay, let me write one equation.
Okay, sir. Yeah.
You tell me one differential equation.
For example, dy by dx equal to y of x minus 1. Let's say this one.
I repeat it.
Y into x of x minus 1. Y into x minus 1.
Yeah. This one?
X minus 1 in the bracket, sir. Let's say this one.
Okay, right.
Okay, sir.
So here the function, it is in the form of dy by dx equal to f of x comma y.
Yes,
so
sir.
here f of x comma y equal to y into x minus 1, or we can have the xy minus y.
Yes, sir.
This is not a homogeneous function, because in the first term product of 2 variables, in the next term only single variable. Here the power of the variable is 1. Here the power of the variables is 1 plus 1, 2. In every term, the same powers are not present. Therefore, it is not a homogeneous function.
Okay, the power should be same for homogeneous.
If we have only numerator function, f of x comma y equal to, we have only numerator function. Then now observe every term powers of the variable.
Okay.
Suppose if we have a function like this, f of x comma equal to numerator by denominator, then we have to check each one separately. Whether these two homogeneous or not, we check it out. Both are homogeneous, total function will be homogeneous only. Otherwise, it is not a homogeneous function.
Yes, sir. Sir, if it is y minus x, then...
If it is y minus x.
Yes, sir. Or yx minus x square, like that.
You tell me a function, y.
For example, xy minus x square, like that.
Tell me. Once again, repeat.
Sir, dy by dx equal to xy minus x square.
Xy minus x square, right?
Yes.
Is it your function?
Yes, sir.
This is a homogeneous function with a degree 2. In every term,
2, yes,
powers
sir.
of the variables is same. What is the power here? 2. It is a homogeneous function with a degree 2 only. But we cannot solve this by our homogeneous method. This function is homogeneous function with a degree 2. But according to our homogeneous method, what is the condition? Dy by dx equal to f of x comma y. This function should be homogeneous function with a degree 0 only.
Okay.
Got it? According to our method, condition is this function should be homogeneous function with a degree 0. But here in this differential equation, homogeneous function, but not degree 0. That is why we cannot solve this by our homogeneous method.
Okay, sir.
Got it?
Sir, earlier while discussing about you're talking about order and degree, that time you told check the highest derivative and then the power of the highest derivative is degree.
That is only for differential equation. That
I
is
was
for
having
differential
this confusion, like dy by dx is the first order.
What is your doubt? Actual doubt?
Hello.
Hello.
Sir, I was saying that like for example earlier you have told for a differential equation we check the highest order and the power of the highest order gives us degree.
Yeah.
Over here we have dy by dx equal to for example xy minus x square.
You
Here
tell me example, I will write down.
same example, sir, previous one only.
Previous one. Which one? Dy by dx equal to xy minus x square.
Yes, sir.
You want to find the degree?
Yes, sir. Degree.
Degree of which differential equation?
Yes, sir. Differential equation.
Now see this. Function is different, differential equation different. Our aim is finding the degree of the differential equation. To find the degree of the differential equation, just consider the highest order derivative in the differential equation. It is the highest order derivative. Its power is 1. That's all. Depend the power of the highest order derivative, we are writing the degree of the whole differential equation. So degree of the homogeneous function is different. Degree of the differential equation is different.
All right, sir. This was the doubt, sir. Because I was thinking like little confusion was there. So homogeneous function we are talking. I mean, having different thing and differential equation is different.
Different.
Okay. Sir.
Right.
Thank you, sir. Thank you very much.
Welcome. Next.
Hello. Good afternoon, sir.
Good afternoon.
This is one small doubt, one problem, sir. Will you note down, sir?
Tell me.
Tan inverse of x into dy by dx.
X into dy by dx
equal to d square y by dx square.
Is d square y by dx square. Right.
What's the degree, sir?
Degree is not possible here.
We can transfer the function now, sir.
We can transfer x into dy by dx equal to, that becomes tan of d square y by dx square only. It is a transcendental function. If this expansion contains infinitely many terms only. So we cannot choose the highest power of the derivative.
You said y into e power x equal to sine of d square y by dx square, one problem now, sir.
Which one? Y plus?
Y into.
Oh, only y into.
Y into e power x equal to?
E power x equal to?
Sine of d square y by dx square.
Sine of d square y by dx square. Now in this case, degree is possible because here on left hand side there is no derivative. If you bring the sine function this side, that becomes sine inverse of y into e power x. It is free from derivatives. Other side we have only.
Instead of e power x, if we have e power dy by dx,
then we cannot write degree.
Why, sir?
Because if we have a e power dy by dx, and this is a transcendental function, exponential is a transcendental, if this expansion contains infinitely many terms, then we cannot write degree only. Remember one point, to write the degree of the differential equation, in the differential equation, derivative terms should be finite number only.
Okay, sir.
Got it? And also power of the derivative should be positive integer. That is a condition.
Okay. Thank you, sir.
Right. Hello?
Hello, sir.
Tell me.
Sir, in 4F, sir.
In?
4F.
4F.
In that second method, we rejected B, no, sir. How, sir?
Option D. You are asking about option D, right?
Yes, sir.
Option D. Actually, by first method, B is eliminated. Only 3 were satisfied with the condition.
Okay.
Second option is eliminated according to condition. So no need to check the second option only.
Always we need to check the first option, method 1 first, and only then we can go to second method.
Yeah. Anyway, generally, if condition is given, we start with the condition only. That is simple one. only one of the options satisfies with the condition, directly we can choose answer. Like is more than one option satisfied, then we go to the differential equation.
Okay, sir. Thank you, sir.
Okay.
Okay, sir.
Hello.
Good afternoon, sir.
Hello.
Good afternoon.
Good afternoon. Tell me.
Hello.
Hello. Tell me.
Good afternoon, sir. Yeah. So I have a small doubt. Well, while regarding solving the integrals, I have seen, taking some taking logarithm and some taking the natural logarithm.
Okay.
So like I need a clarity on when to use what, because in other subjects also we might get the similar kind of integrals, and sometimes you use log and sometimes you use ln. So I need to get a clarity on this.
Now I'm writing this one. Look at both.
Yeah.
ln of something equal to log something. Both are same here. On right hand side here, in place of base, I did not write anything only.
Yes,
if I do not write anything, means it is understood that log of something to the base c. That is these two are same. Actually, we should not write this one. But usually, instead of writing the ln always, we write the log of something. Base is not mentioned here. That is why base is understood at e.
Okay.
Something is given, then both are different.
Yes, sir. So the standard formulas also which we have in the integration, it's basically loge.
E only, loge.
Unless and otherwise mentioned, right?
Suppose if we have a formula like this, d by d, suppose d by dx of log x. Let us look at this. Actually, it is a ln x, not based on base e only. So its derivative is 1 by x, right? Suppose if you are asked to find the derivative of like this function y equal to log x to the base 2 like this. Directly we don't have formula.
Right.
We have the formula only for base e only.
E only, yeah.
So we convert this to base e only. Log x by 2. That is log 2 only. 1 by log 2 means constant. For log x to the base e means we have a formula. That is the difference.
Thank you so much. Thank you so much.
Okay. Hello.
Hello, sir.
You can ask your doubt.
Sir, I have a doubt in the question. Y dx minus x dy equal to 0, sir.
Y dx plus?
Y dx minus, sir.
Minus. Okay.
Minus
x dy.
X dy equal to 0.
Okay. What is your doubt?
Sir, if we solve this by variable separable method, sir, once you solve a variable separable method,
okay, sir. Okay. Variable separable means direct here, y square.
Sir, we can write dy by dx.
Dx by x minus dy by y, right?
Yes, sir.
Log x minus log y equal to c. Log of x by y equal to c. X by y equal to e power c, or just c. It is answer.
Sir, sir, okay, sir. Sir, sir, in textbook, in some of the textbooks, while I was solving, they will take for constant c as ln c only, sir.
No problem. Actually, when you get like this, while integrating the function, suppose look at this one.
Okay, sir.
Integral of 1 by x dx plus y dy equal to c only. Okay. Now in the first term integral is log x.
Yes, sir.
Plus second one y square by 2 equal to c. Here both terms are not getting log. In both terms, if we get log, then we can take the c also log c.
Oh.
To eliminate log on both sides.
Okay, sir. That was my doubt, sir. Means when to take ln of c and when to take normal.
Also, we can take log c directly, no problem. Directly, you can get the xy by equal to c only. Because in both terms, we got log only.
Okay, sir. If LHS is consisting of all logarithmic terms, then we can take for constant
log.
also log.
Right. Directly, we can eliminate log 1.
Yes, sir. In some questions, they have given like this, sir. That's why I got doubt, sir.
In some books also, they will write only c as log c also. Even if you get like this also. Because log c in both are constant only. Doesn't mean. When all terms are with log, then to eliminate log, we take the c as generally log c.
Okay, sir. Thank you, sir. That was my doubt, sir.
Right.
Right, sir.
Next.
Hello.
Hello. Tell me.
Sir. So I have a doubt in yesterday's class. When we were solving for variable separable method, there was a note that you gave that if dy by dx equals f of ax plus by plus c,
right,
then that is a linear expression, right?
Yeah.
And then we can reduce it to a variable. Yeah. Then we can write ax plus by plus c equals z and then solve it, right?
Yeah.
So that so it doesn't necessarily means that that form or that expression should be linear. It can be non-linear as well, right?
Anyone non-linear, but only in place of variable we should have linear expression. So if any function is a function of this, generally we write the function y is a function of variable x only. Y equal to function of x square means throughout the function in place of variable we should have x square. That is like this, x square plus e power x square. Wherever the variable exists, in place of that we should have like this x square.
That form of expression.
So in place of x we should have this expression only.
Okay, it doesn't mean that it should be linear, right? That's what.
Yeah, correct.
Okay. Thank you, sir. Thank you so much.
Okay. Hello.
Hello, sir.
You can ask.
Sir, if we consider a differential equation like
dy by dx.
e power dy by dx.
E power dy by dx.
Dx is equals to d2y by dx to
d
second derivative of y by.
Right.
Yes, sir, whole cubes.
For second derivative whole cube.
Whole cube. So now degree of this equation will become 3 now, sir.
No. Actually degree is not possible for this because on left hand side we have a transcendental function of derivative.
Sir, degree is related to highest order.
Highest order derivative, but there is some condition. Condition is like this only. Number of derivatives should be finite. Derivative terms should be finite.
Should be finite.
Finite. Throughout the equation, throughout the differential equation.
Okay.
That is the first condition.
Okay, sir, thank you. Okay, sir, thank you.
Hello.
Hello, sir. Am I audible?
Yeah, audible. You can ask.
Sir, I have doubt in finding the degree of the equation, sir. Can I say that equation?
Degree of the function or degree of the differential equation?
Differential equation, sir.
Okay. You ask.
D square y by dx square.
Okay.
Whole power 5 by 4. Plus dy by dx whole power 3 by 8.
Okay.
Plus sin y equals to 0.
Right.
Degree is possible, sir?
No, not possible. Degree is not possible. We cannot eliminate these fractions.
By multiplying the power with 8, it is possible, no, sir?
By multiplying with the power?
8.
Not possible.
It becomes integer, no, sir?
Suppose this is not there, degree will be possible. We can eliminate the power, a fraction only. With the sin y, we cannot eliminate them.
Okay. With sin y, we cannot eliminate them.
With the sin,
okay, sir.
Without sin y term, only these two are there, we can eliminate only. Just shifting this other side, we can eliminate fraction. So that we can get the degree.
Sir, okay.
Okay.
Okay, sir. Okay, sir.
Right.
Hello, sir. Sir.
Tell me.
Hello.
Hello.
Why we can't eliminate that sign y, sir? Because it is containing infinite terms.
Okay, but that is a
Hello.
sign is a function of variable y.
Just it is a variable of y only, no, sir. It is not a variable of differentially. Means it is not a function of derivative, no, sir.
Look at this. I am writing something. If you want to eliminate this power 1 by 4, you should take whole power 4 on both sides. So these two get cancelled, we get 5. But other side, if you expand this, this power will not be removed.
If we take all power 8, sir, then it will both side will be cancelled, no, sir. Then both side will be power will be integer only, no, sir.
Both sides power. If you take
yeah,
power like this 8.
Yes, sir.
D square y by dx square power 5 by 4 whole power 8 equal to sin y minus dy by dx. Here what is the power here? Already 3 by 8.
3 by 8 whole power 8.
Whole power 8. If we expand this, after expanding this, we get the 3 dy by dx 3 by 8 power 8 next to 7, like this we get the different fractions only, just like a minus b whole square.
Okay. Okay, sir.
In some terms we can have the again fractions only.
Fractions. Okay, then it is difficult to eliminate, so
Yeah.
we can't say the degree. Okay, thank you, sir.
Right.
Good evening, sir.
Good evening.
Sir, how is regarding the degree of the differential equation, sir?
Okay.
Sir, write a problem, sir, on exam.
Right.
I'm saying.
dy
by dx whole square.
Dy by dx whole square
is equal to 3x by 4y.
3x plus 4
3x
y.
by 4y.
3x by 4y. Okay.
That's it, sir. So, what is the degree of the differential equation?
Degree 2.
Sir, can't we write that 2 as a root of for this? 3x by
No. After simplification, it is a derivative power. We have to observe the derivative power on.
Okay, sir. Next doubt is, when you are saying
if it is not integer, then you have to simplify this. Otherwise, not required.
Okay. Sir, another doubt is in exact differential equation. You said that if the differential equation of the form mx plus mdx plus mdy, if we write as m and n in the
d of
as the same function, as some function, it is said as exact differential equation.
Yeah.
But you said another equation that dou m by dou y is equal to dou n by dou x.
That is a condition. This is a condition of the differential equation.
So what is the difference that between two, sir?
No. Actual definition is this one. Condition is this. Condition is d of u of x comma y equal to 0 from m dx plus n dy equal to 0. It is a condition of. This is the definition. That is a checking the condition of the exactness. Because for every differential equation, we cannot write this in this form only. Writing the two terms as single term is not an easy. That is why we are going for necessary and sufficient condition of the differential equation.
Okay, in homogeneous differential equations, also y by x is equal to the condition.
Okay.
That's it, sir. Thank you.